Hi, welcome to a video tutorial from Robojax. In this video we are going to learn how to use ESP32 to measure any DC voltage. As you can see, we are measuring DC voltage of 20 volts, and here it's shown I can reduce the voltage and we can see it in here on the serial monitor. I'm increasing it now to 30 volts almost, and we can read it in here. Let's get started with this. ESP32 starter kit from SunFounder. This is the best ESP32 learning kit from SunFounder. It has this ESP32 microcontroller which has built-in Wi-Fi and Bluetooth. This board can do everything Arduino Uno can do or many other Arduinos can do, plus extra more features. Because we have Wi-Fi and Bluetooth, the possibilities are endless. You can get connected to the cloud or do the control or read information or values via your mobile device or your desktop or over the cloud from a far location. It comes with a camera extension kit where you can stream the video over Wi-Fi either through the cloud or to your network, and also it comes with micro SD card where you can save images on the micro SD card, or you can write from the device any information, log the information on the device and read it back. You can power the board using this included 18650 lithium battery, and it has built-in charger where you can connect micro USB and charge the battery. The kit comes with 320 pieces of component that you can learn tons of projects. There are many instances that we need to measure DC voltage. We had in the previous lesson we introduced how to measure the voltage from potentiometer, which we connected it to 3.3 volts of this pin, and we were able to read the voltage. But sometimes you need to measure higher voltages. For that, I have made this video so we can use two resistors as voltage divider, and we make sure that one resistor voltage will be measured and the remainder of the voltage will be dropped on the second resistor. So this way we can virtually measure any voltage. But of course you cannot go thousands of volts because there are some insulation, and even with plastic insulation there will be sparks, so you cannot go beyond certain voltages. For that, please refer to the safety code of the region or school or organization that you are living. But we can go, for example, 30 volts, 24 volts for the voltages of battery or something that you need to measure. It will be easy to use with these resistors with some precautions. So we are using two resistors. One resistor that I'm using is 10 kilo ohm. These are all 1% tolerance metal film resistors, the blue one. So get 1% tolerance resistor, and then the other one will be changed accordingly. So this way we can measure the voltage, and also we will reduce the amount of current that is consumed by the circuit. So keep one resistor at 10 kilo ohm, and then the rest we can change it. In order to find what resistor you need for what voltage, I have created a function in the code where you can calculate resistor. Just uncomment this and run the code, and this is R1, which is 10 kilo ohm at the top, and just enter your voltage, for example 24 volts, and run the code. Once you run the code, automatically it will tell you what kind of resistor you need for 24 volts. Just wait. So this was the previous information. Let me press the button here. It says for our calculating R2 when R1 is 10 kilo ohm, the maximum input voltage is 24 volts. R2 should be 67 kilo ohm. This number is not critical, so whatever higher closest value that you have, you can use. Or to be safe, just use 72 kilo ohm, 82 kilo ohm, or maybe 93 or maybe 100 kilo ohm, it's very acceptable if you use those values. But regardless, you can have proper closest value if you want to make it. Once you're done, just comment this out, and you don't need it. And also in the code, I have set debug feature, so when you run it, it constantly, if I set this, for example, to true, right now it's uploading, it will give you the input voltage that we are reading and the resistor value. So now, to understand the circuit, we are having from the battery or source that we have, we want to measure the voltage of B1, VB1, and we are using two resistors, R2 and R1. So the voltage comes and it is divided on two resistors. For R1, we call it VR1, and for R2 will be VR2. And we are measuring the voltage across R1, which is 10 kilo ohm. So ground and VN, this is connected to our microcontroller. And this voltage, to calculate this voltage, this is the formula. We can drive it very easily. So VB1 is equal VN, this VN, 1 plus R2 over R1. So this is the formula. And from this formula, if you need to know R2, we can just drive it. R2 is equal VB1 minus VN over R1. So you subtract this and divide it, you will get the amount of R2 for certain voltage. For VB1, let's say you want to find the voltage for the battery, which is 200 volts or whatever maximum you want to work with, 24 volts. For simplicity and for safety, VN, I've set it to 3.1, so we will not allow anything above 3.1 to be safe. And when we put this in the formula, the calculation will be very accurate. And because we are selecting R1 to be 10 kilo ohm, we have, let's say, a voltage of 100 volts, VN is 3.1, so just plug in the values and you will get the R2, and it will work fine with your calculation. When you use ESP32 with SunFounder's ESP32 camera extension module like this, it comes also with a battery on the package, and it comes a built-in charger, so you can connect it and charge it and disconnect, and later on you can use it with a lot of power, so you can power up your application very easily. I have connected a 10 kilo ohm resistor to a point where it is connected using this wire to this blue line, and this will be my ground. And then from this point I have a 100 kilo ohm resistor. You can change it, I will show you the calculation, to another point. Our voltage will be connected, our source, for example, my source voltage will be connected like this. So this is connected. Now I need to connect from the point where the two resistors meet. We will measure this voltage. It is connected to pin 35. And if you are using just ESP32 without this extension board, you can connect the wire here to 35, which is labeled here. And for the ground, we must bring a wire here from the second pin either, or from this second pin to this point, so we can have ground. Now let me explain the code. I've defined here an integer constant. I called it R1, and I've defined another variable R2 of type integer constant. So this is 10 kilo ohm, this is 100 kilo ohm. We can change it. This should be not changed. I suggest we just play with this. And this is another constant VN pin where we connect across the R1 to measure the voltage. In this case, 35. This is the frequency for the pulse modulation. The resolution is 12 bits because we want to measure the higher resolution that is offered by ESP32, and we are using channel 0. This VB1 and VB1 is the voltage that we are measuring, the battery voltage 1, and integer millivolt. This is the input voltage in terms of millivolts of type integer. Do not change them, they are used by the code. And inside the setup, we initialize the serial monitor with 115,200. This is initializing the LEDC setup with channel, frequency, and resolution that is coming from these three informations. This calculate resistor is a function that I've written at the bottom of the code. At the bottom of the code, this should not run only unless you need to calculate, for example, certain voltage. You want to find out what kind of resistor is needed for the amount of R2. So this is calculating R2. Just uncomment this and it will calculate and print it for you. Inside the loop, this function, which is at the bottom of the code, reads the voltage, and these three lines are just printing this text and actual VB1 and the symbol V. And we have 500 millisecond delay. It will run continuously. Now, read voltage. When we run this read voltage, it comes to this function, and the function and we use analog read millivolts. This will directly read the millivolts, and we pass the VN pin, so this will give us the voltage in terms of millivolt. And then debug, which is at the top of the code, if it is enabled, then we print the maximum voltage, which is another function based on these two resistors. It will tell you what is the maximum voltage, so you can take precaution not to damage your microcontroller. So I'm going to explain that, and then it will print the voltage, the millivolt. So this is just printing it, and then the millivolt is now stored in the MV, which was at the top of the code, and this line is calculating the voltage. This is exactly this calculation that you see here. We get the millivolt, the input voltage. This one divided by 1000 makes it volt, so this doesn't matter, and then we multiply. So this is inside the parenthesis, and then we say 1 plus R2 over R1. This is R2 over R1. We just put float. This is called casting. We are changing the type because R1 and R2 are integer, and we want to get the result in terms of float VB1. That's why, so this is a calculation, and the VB1 is a variable at the top of the code, so this will update it. Now, maximum voltage is a function that does the same thing. So for precaution, so maximum voltage is a function that does the same thing. It just calculates the maximum voltage and it will print it on the serial monitor. Calculate resistor is a function that when you uncomment it from the setup, it will receive the value of R1 and it will receive a float voltage value, and it will print all these text up to here, and it does a calculation to give you the R2. And R2 is calculated using this formula, and I've implemented in here. So this is exactly this, and we will divide it by 1000, and we will get in terms of kilo ohm. And sorry, we will divide it by 1000 and we'll get it in terms of kilo ohm, while one means stay here and never go forward, so it will stuck forever and as long as we have the power. That's why when you run this function, make sure to comment it after that, so you just need to print once the information and then comment it out. And if you need to use or work with the voltage, this is a voltage, you can do whatever you want. It's a float value, just do your task in here. Now let's see how we can select the ESP32 board. We can click here under the select board and type here ESP32 DEV. As soon as you type dev, you will see dev board. You can select it and click OK. So the board has been selected. Now we have to select the port. The other way to select the board is click on Tools, Board, ESP32, and select the ESP32 dev module. Now we have to select the port. If I click here, it shows 2 ports, and I don't know which one belongs to my device. Sometimes you will not see the number properly. So the best way to be sure, right click on the Start menu, go to the Device Manager, and you will see here the ports. If I click on this arrow, it will show me the ports. One is USB serial CH340, the other is USB serial device. And here, now it's connected. If I disconnect this, one of them disappears. The one that disappeared is my board. So 6 stays and 8 disappeared. If I connect it, so 8 is my COM port, CH340. Now 8 is my COM port and I can select it. Or I can click on Tool, Port, and here you will see it. You can select whichever you want. Ours is COM8. Now we have successfully selected the board and the port. And this is very important. It must be done first. I've connected my power supply at this point. One wire is connected, and here on this side of this R1 resistor, and this is connected to the input of GPIO 35 to pin 35, and this is a 100 kilo ohm resistor connected to my main power supply. So we have used this as a divider, and from the middle we are just reading the voltage. This is at the moment the voltage that is coming from my power supply. Here, if I disconnect it, you will see that the voltage is now 0. I'm connecting it back. This is the voltage, and as you can see, we are reading the voltage here on the serial monitor. I'm increasing it. Here 10.24 or 10.23. Now I increase it again, and we are reading the voltage on the serial monitor. As you can see, the voltage is fluctuating, but here the voltage is fluctuating and this voltage is also fluctuating. But if you want a more steady voltage, then we can do the average. Just create a loop and measure 10-20 measurement, and then take the average and display it. That way the fluctuation will be reduced and it will be very stable voltage. Now if we turn on the debugging here, this line, if I say true and upload the code, you will see that it shows all the information, including the resistor, the input voltage at this point, because this is a voltage divider, and we see all the values, which will help you understand better, and also maybe for debugging purpose. Here, let me stop this. So it shows the actual voltage 2.33, and maximum voltage with the current configuration of these resistors, we can measure 34.1 volt, and the pin voltage that is coming to this point is 2032 millivolts or 2.03 volts at the moment from this resistor, but the total voltage is properly displayed, which is this voltage. This is now fluctuating, and if you need to know, for example, if you need to know for certain voltage the amount of resistor, I have set this function here inside the setup, calculate resistor. Just uncomment this, and here we have the R1. We want to use 10 kilo ohm resistor, but we don't know the R2 and your maximum voltage. Let's say you want to measure a 100 volts. Let's upload it. It will calculate R2 for you. Let me clear the screen. I'm now pressing this reset button to get the value. Here it says calculating R1, R2 when R1 is 10,000 ohm, maximum input voltage is 100 volts, and R2 should be 312 kilo ohm. So you don't need to have 312 kilo ohm, maybe 330 kilo ohm resistor, which is a standard one. You can use that, and the calculation will be accordingly adjusted, and you will get very accurate reading of maximum of 100 volts. So very useful. Once you're done, just comment this line out, and it will not be displayed. And now, as you can see, we are reading 22.9 and here 22.8. The discrepancy of few hundred millivolts is due to the 1% tolerance of the resistor with 100 kilo ohm. That's still acceptable. And here I have replaced the R2 with 330 kilo ohm resistor, and I have entered here 330,000, and as you can see, input voltage is 30 volts, and we are reading 30 volts. Let me reduce the voltage for some random value, 23.3, and here 23.1 or 23.0. We are reading 300 millivolts discrepancy. For such a large amount of resistor with 1% tolerance, that's acceptable. Let's go lower. 13.6 volts or 13.5. This is 13.3, so 300 millivolts discrepancy, still acceptable. Now if I reduce the voltage, even with the minimum, we are reading 1.6. So minimum voltage is 1.5 at the device, and this is due to the internal reference voltage. So we cannot go below this, and this is the voltage is 0, it shows 1.56. So that is the reference internal reference voltage, and if I increase it, as soon as it reaches 1.6, after that we can read. So 1.5, still we are not reading anything. As soon as I increase it, the reading started.